For this session, we have 5 presentations, and the first is artificial bee colony algorithm for future selection in fraud detection process.
Hello.
Hello? Are you the...
Yes, I'm the presenter of the
Okay, perfect.
first one.
Share your screen, please. Okay, perfect.
So may I start?
I see the screen. You start if you want.
Okay, thank you. So I'm Fabrício. I'm presenting this paper, Artificial Bee Colony Algorithm for Feature Selection in Fraud Detection Process. It was developed mainly by Gabriel and Vitória, who are the first authors. They developed this article during they are graduate students. They developed this article while they took my nature-inspired computing class. So this is the agenda of the presentation. I'll start with an introduction. So first, the problem, the fraud detection became indispensable for companies nowadays because people are increasingly doing banking operations, shopping, using their smartphones and internet, and there are many fraud attempts, especially during the pandemic. The amount of frauds increased. So machine learning techniques are being used for this purpose. Many of these techniques use supervised learning and some hybrid approaches. And the data sets that collect financial transactions, they have to deal with a huge amount of attributes because many of them are, some of them are relevant to the problem, but many of them are irrelevant or redundant, and this makes the search for patterns a little more time consuming and taking computational resources. And sometimes you have worse accuracy because you are using features that are not relevant. So to avoid this problem, we may use feature selection techniques to keep only the features that are relevant to the problem being treated. So in this work, we used the artificial bee colony algorithm as a feature selection method. And it's also used as a parameter optimizer to feed the other algorithms that find the best features, like K-best and RFE. ABC is known by its simplicity, and it has good results compared to other optimization algorithms. It needs just a few parameters to work. Other methods usually have more parameters to set, and it can easily be adapted for hybridization. So it's a good choice for this kind of task. The artificial bee colony algorithm was created in 2005, and it was initially used for numerical optimization, and it simulates the foraging behavior of the honey bees. The bees, the worker bees of the colony, they are divided into 3 groups. They have the scout bees that they are randomly looking for food source. When you see a single bee flying around, it is usually looking for some food source, the scout bee. Then we have the employed bees who are responsible for one food source They are exploring one food source in specific. They are evaluating this food source and bringing samples to the hive. And then we have onlooker bees, which they summarize, they evaluated the information, the samples that are brought from the other employees, and they decide which source should be exploited. If they have many food sources, they will choose one to exploit first. And food sources represent possible solutions to the problem. So they are evaluated through objective function, and the algorithm works iteratively until some stop condition is reached, and then the best solution is returned as the solution to the problem. Here's a fluxogram, how this works. So the scout bees are initialized random on random food resource. The employed bees calculate the probability of a source being chosen by the quality criteria. The onlooker bees assess the amount of nectar from the food sources the other employees found, which is the quality of the solution. Then they check if there are some stagnant food sources. If there is, they have to send scout bees to find the other food sources. If not, they save the best solution, which is obtained until that point. If the stop criterion is not reached, they have to go back to this task here to employ bees calculate the probability of the source again. When they reach the stop condition, it ends. So the proposed work, first step is to look for a data set to train, test and validate the model. And so this was the chosen one, the credit card transactions fraud detection data set, which is public available at Kaggle. Second step was implementing the ABC using Python. They chose to use Python because it has a large number of libraries for machine learning, for statistics, and so on. They created the B class, which attributes was the food source, quality of the source, and if it's stagnant or not. The objective function to be optimized is performing the train test process using one of three different classifiers and evaluating the results to the F1 score and accuracy. These are the three selected classifiers: logistic regression, gradient boosting, and random forest. And the objective was to search the set of attributes to reduce the final error, increase the F1 score, and leading to the better classification results. Regarding the computational complexity of the ABC, it is exponential time, and feature selection is a NP-complete problem. So some results and discussion. Three scenarios were proposed. So the first one, ABC used it for feature selection, and then the other three classification methods were applied to classify the data set using the attributes that were found by the ABC. In the second scenario, this is the baseline. The three methods were applied to the whole data set without feature selection. They used all the features. In the third scenario, ABC uses to find the best amount of attributes using other selection mechanisms like K-best, RFE, and feature importance. So in this case, ABC is finding the best parameters to these methods. And these methods will perform the feature selection, and the same three classifiers are used. Each scenario was executed 100 times because of the stochastic nature of these methods. And the ABC parameters were the maximum number of interactions, 100, the number of B's, 10, and the stagnation limit, which is set to 5. And here we have some results. Using the gradient boosting, we have the ABC selecting features got the results a little worse than when all the features are used. And when we use one of these feature selection methods, using ABC as the parameters to set their parameters, they have this the same accuracy than the baseline. This happens in gradient boosting, in random forest, and logistic regression is a little different because in this case it was actually the worst classifier, but there's a lot of improvement when you use ABC as the feature selection, as a feature selector. And when you use the other feature selectors, 2 of them are worse than the ABC, and this one is better. K-best was the best one. Of course, we would expect a little better results with the ABC as the selector, as the feature selector, but when we are able to keep at least the same accuracy than the baseline here, it's also good because when you have more features, the classifier will take longer time to train. So we get a faster training when we have less features. And here are the F1 score results, which are basically the same which we saw with the accuracy. The values are pretty much the same here. With random forest, we have the best F1 score with 99%. Achieved when we have one of these methods for feature selection using ABC to set the parameters. So all tests were performed on a laptop with Windows 10 operating system, 16 gigabytes of RAM, and a Intel Core i7 processor. 2 different situations were observed for the gradient boosting and random forest classifiers. Using the ABC algorithm, it doesn't change the accuracy and the F1 score of the results. So the biggest difference is saw when there is a direct application of the algorithm to select the attributes. This is the scenario 1, in which the results end up getting worse by 1%. So here, we conclude that there isn't much difference, but we can use the feature selection to decrease the complexity for the classifier and possibly taking lower time to train. So, and the other situation is that for the logistic regression classification model, there was an increase in performance both for the accuracy and the F1 score for both scenarios 1 and 3, related to scenario 2, which is the baseline with no attribute selection. So this article presents a new feature selection technique based on the ABC algorithm. The results show reduction of the database complexity, which is good, and achieve a higher accuracy of classification in a few scenarios than that obtained with the complete set, the complete data set. These results obtained corroborate the quality of the ABC as a proper method for feature selection. This validates the hypothesis that the algorithm could reduce the cost and increase the quality of the results obtained in a fraud detection process, which is so important nowadays. Also, the results are comparable to other state-of-the-art methods, and a fact that encourages its usage for such tests, and it should probably be evaluated in other data sets in order to find out if it really rolls as a feature selection algorithm. ABC can also be used to optimize the parameters from other feature selection methods, which is a secondary task, which is also influences the quality of the results. So we have several methods to perform feature selection, but many of them have lots of parameters to set, and so you are solving a problem, but you have another one to find which are the best of these parameters. So ABC can also be used to set the best of these parameters. And well, that's it. Thank you.
Thank you, Fabrizio. Any question? No? Okay. The next presentation is automatic features extraction from the optic cup and disc segmentation for glaucoma classification.
Hi everyone.
Hello?
I will present this paper to you. My name is Marcos Oliveira.
Are you the presenter?
Yeah.
Okay. Share your screen, please. Okay.
Okay.
Yeah.
Can I start?
Yes, yes. Thank you.
Let's go. Ladies and gentlemen, good afternoon. My name is Marcos Oliveira. I'm a MSc student of Federal University of São João del Rei, Minas Gerais, Brazil. First, I apologize for my bad English, and I'm so glad to present this paper to you. And I will try. I will do my best on it. The title is Automatic Feature Extraction for the Optic Cup and the Disc Segmentation for Glaucoma Classification. The authors are Marcos Oliveira, Cleves Vieira, Ana Paula de Filippo, Diego Dias, Marcelo Guimarães, Elisa Tuller, and Leonardo Rocha. This presentation will follow this script. In introduction, I will explain a little bit about the glaucoma and its diagnostic methods. In the theoretical reference, I will explain some characters that doctors observe in fundoscope images, for example, the CDR and the Eason Road and the BVR. And related works, I will talk about two approaches of fundoscope image analysis for glaucoma classification. In your proposal, I will show you the new methodology developed step by step from the fundoscope image input to the feature extraction and the glaucoma classification. I will show as well the proposed evaluation and its results. At the end, I will follow to conclusion and future works. The glaucoma. Glaucoma is a chronic disease with a slow and progressive course characterized by degeneration of glandular cells. It is leading cause of irreversible blindness worldwide. One of the most important risk factors is intraocular pressure, when increased, leads to great excavation of optic nerve. Diagnosis is based on clinical evaluation, assisted by optical coherence tomography, the OCT. And what is the OCT? A custom examination that consequently it is not accessible to entry population. In addition of this approach, retinal fundus image analysis is also used. That is, the doctor manually examines various factors, including the extent of excavation, to determine the suspicion of glaucoma. About the analysis of retinal fundus image approaches, the doctors observe some features, for example, vertical and horizontal CDR. That's it. The ratio between height and the width of the optical disc and cup of disc. In the left figure, it is possible to see the vertical and horizontal CDR, when the vertical CDR is acquired by ratio between little v and the big V, and the horizontal CDR is acquired by ratio between little 8 and the big 8. That is the left figure. In the ISA rule is about the area between the cup and the disc boundaries. The green and rectangle, the green and the rectangle in the red rectangles. In the healthy eye, the inferior area should be greater the superior area. The superior area should be greater than nasal area, and finally the nasal area should be greater than temporal area. All of the areas showed on the middle figures, where we can see the rule applied on the healthy eye. The right figure shows the blood vessel ratios, BVR, which decreases as a disease progresses. Related works. There are a lot of works and papers about the automatic glaucoma classification. Basically, they are divided in two approaches: deep neural networks and traditional imaging process techniques. The deep neural networks perform great accuracy diagnosis, but they need a large amount of training data. They may not be readily available and require large amount of GPU memory to train the model, increase the prediction time. The, uh, Otherwise, the traditional image process techniques perform a good accuracy in diagnosis, with additional advantage of not requiring a large amount of training data compared to deep learning models. But it is still a heavy computational cost associated with extraction features. The new proposal is based on traditional imaging process techniques and go through to the following steps. 1. Find the region of the interest. 2. Standardize and enhance local image contrast. 3. Perform up-to-disk segmentation. 4. Perform up-to-cup segmentation. Actually, the segmentation process are the limitation process, because we don't separate on parts of the images, just delimiting in its boundaries. Continuing. Number 5, calculate the attribute related to vertical and horizontal cup to disk radius. 6, determine the eye direction, right or left. 7, compare the integrity of ISA pattern. And finally, number 8, calculate the density of the blood vessels. In the slide, it is showing all the generated image by algorithm to acquire the features from the eye fundus image. We'll start with the input image, the left figure. Next, we can see the finding of the region of interest. After, the performing the histogram process, followed by the disk and cup segmentation. In the last image, we can see two rectangles, green and red, delimiting the optical disk and cup of disk. Besides, it shows the list of tabular attributes generated by methods. That is, image file name, the eye direction, the vertical and horizontal CDR, and the ISAM pattern, all the ISAM pattern, and the BVR. To the proposed evaluation, we use the Origa dataset. The dataset is composed of the 650 images with 482 are healthy eyes and 168 glaucomatous eyes. And we use the SVM support vector machine as a declassifier. On the right side, there's an attribute table of labeled image provided along with the Origo dataset by Kaggle site. In this table, It is not that. It has only two important attributes, the CDR and the iDirection, besides the image of file name and the set, um, a kind of attribute, the source of images. So we compare the SVM classifier performance on the attribute table supplied with dataset and the attribute table generated by our proposal. The results show us the classifier performed better on our attribute table than the table provided with dataset, reaching 0.81 FU score against 0.64 of another table attribute. The FU score is a good metric to compare that, because it is a harmonic mean between recall and precision, giving us an overview performance. In spite of these good results, a manual inspection was conducted on some misclassified images. It, it was and it was found that the feature extraction was not performed correctly on it. Below, we can see three examples of it. We can see the rectangle. The rectangles are misplaced in the images, which decrease the quality of the attributes acquired by algorithm. So, as the user dataset has an image database with the official markings defined, that is, the quantitative characters duly annotated, a comparison process by cosine similarity was done between the official marking segmentation data and the data obtained by the segmentation method proposed in this paper. The result was good, reaching 0.82 F1 score when the similarity index set it to 80%, when and 0.83 when the similarity index set it to 85%, 0.86 when did it set to 90%, and finally 0.95 when similarity index set it to 95%. Besides, we we performed the SHAP and the Lemme algorithm on the results to know which attributes was most important to classify performance. What is the SHAP and the Lemme algorithm? This kind of algorithms use it to explain the features importance of machine learning models. So after running it, the Lime algorithm shows the main features used by a classifier for glaucoma classification. Just like it was done with a Lime algorithm. Mm, we run another algorithm of the same class, the SHAP. About the results of SHAP and Lime algorithms, both one shows the importance of the extracted attributes from the iFunders images by our method. That way, the ISA rule and BVR followed CDR were the most considered features by classifier, as shown in this image. Mm, The results show us the importance of segmentation process on the glaucoma classification, reaching FU score 0.95 when the similarity reached 90, 95%, concluding the more accurate the feature extraction, the higher to accuracy of the classifier. To the feature works, it is necessary to test the proposal method with other available datasets and improve the segmentation and normalization process of images to enable segmenting a large number of images with a higher quality. Or refers used in this presentation or described in the paper. Thank you so much.
Thank you, Marcus. Any question for Marcus? No?
Thank you.
Thank you, Marcus. The next presentation is implementation of explainable artificial intelligence, case study on the assessment of movement to support neuromotor rehabilitation.
Hi, I'm here.
Hello, hello Luis. Okay, perfect.
My name is Luis Felipe. I am a doctoral student in computer science at UNESP. I will present this work based on my studies carried out for my thesis. I will present the paper entitled Implementation of Explainable Artificial Intelligence Case Study on Assessment of Movements to Support Neuromotor Rehabilitation. The use of artificial intelligence consisted in providing data to a model in the process called training, so that this model identifies and starts to replicate the patterns that solve the problem and can be applied to another datasets. However, an internal structure of the model can reach a level of complexity that is difficult to understand, especially for average user. The main objective of this study is to present a systematic review of literature on the implementation and so-called explainable artificial intelligence, an area of knowledge that seeks to resolve the problem of understanding that's the evolution of artificial intelligence cases. From this, we seek to develop a proposal for application of XAI in the evaluation of movement in rehabilitation. Artificial intelligence seeks to explain how artificial intelligence to achieve the results, pointing out the most important features for the results in the data. The question that guided the review was how does one implement XAI? The main question has been expanded into smaller questions that give more detail. The search was conducted in several databases using the highlight search strings. The first stage, the selection of students, several inclusion and exclusion criteria were used. With the articles selected, after reading them thoroughly, the data from each article was extracted with the following structured form. In this picture you can see an overview of revision steps. A look at the distribution of studies over the last 5 years. The review studies organized by the objectives. Well-balanced split the timing of the explanation generation. Analysis of which artificial intelligence model are compatible with explainability tools. The explainability supporting libres in the file in the review. The use of visualization and process of explainable was analyzed, categorized according to a taxonomy obtained from the literature. It was found that a good number of the studies don't propose evaluation with users. Several explainable tools were analyzed, evaluating their areas of application and their ways of integration with artificial intelligence tools. The visual resources used in the process of evolution of the area are also analyzed. The review was relevant because the number of studies analyzed and the search process used. As a limitation, we can cite the use of automated search methods and the leak of complete and clean information in parts of the articles. The proposal is to create the pose estimation tool that Truggle explainability can evaluate the pose, indicating the points to be correct, improving the quality of exercises in rehabilitation scenario, especially from post-stroke patients. Two solutions are implemented as a proof of concept. The first solution detects the points on the person body in a video and reconstruction the pose in three-dimensional model. Another example of the first solution. The second solution can evaluate also through a video the angle of personal trunk indicating the inclination. Another example of the second solution. Both solutions are tested in rehabilitation exercise video, first by reconstruction the pose, then evolution the angle of the trunk. This study is relevant because the increasing relevance of XAI, especially in healthcare area. Collaborating with the relevance of the studies, we have a literature review and the case study proposal. The relative new research field limits the collection of information on the subject. Will limit yourselves to a single area for the development of case study. Thank you.
Thank you for this presentation. Any question for Luis Felipe? No question? Okay. Thank you, Luis. The next presentation is Knowledge Management Model, a process view, but I don't see the presenter. Who is the presenter? Go to the next. Explainable Artificial Intelligence, a study of sentiments about vaccination in Brazil.
I'm here.
Okay.
Go again.
Yes. Okay.
I will present this study based on undergraduate thesis by the students Elisa and Giovanna, entitled Explainable Artificial Intelligence, a study of sentiments about vaccination in Brazil. Sorry. The popularization of artificial intelligence raises concerns about ethics, discrimination, and privacy. Many algorithms are complex, begin a mystery to average users and even to advanced users and developers. The recommendations algorithms and fake news end up dangerous influences on people's opinions about important issues. An example is a COVID vaccination. With this, the main objective of these studies is to analyze the Brazilian population's feeling about vaccination. After obtaining developer authorization from the Twitter API, the appropriate libraries were used to collect the 2,000 tweets per sample from August to December 2021. The data extractions were done at the beginning of each month between the 18th and 12th day, considering the posts in Portuguese and disregarding retweets. The sources was performed using the following terms. Each tweet is returned CSV format as you can see. Some attributes are selected because they are important for the analysis. That user field was trained to get the information of the states of origin in the post after that the data was organized in a structured way. A new column was added to the data, and after reading the full text of the post, it was filled with information about the post being for or against the vaccination campaign in the country. Posts not related to vaccinations were discarded. The official campaign guidelines provided by the government were used for rating. There were problems in classification posts with irony. Many posts take advantage of the visibility that the theme has gained, citing related works even without direct relation with to the theme. Distribution of total tweets in favorable, and ignorant. Distribution of total tweets by devices used. Distribution of total tweets by the states from the origin of the posts. Percentage of favorable and not favorable by the states. After normalizing the data, the textual information was translated in the numerical values and through appropriate libras, the model was trained. The data was divided in 18% for the sample for training and 20% for the sample for testing. A logistical regression model was used via scikit-learn library. Several metrics for evaluation the model were used, indicating the satisfactory training result. A first step in evaluation explainability is a word cloud typography was produced based on all set of all valid tweets. Then the same type of graphic was generated, but considering the posts in favor of vaccination. And finally, another word cloud graphic, but considering the post against vaccination. We apply the line explainability library to a pro-vaccination sample, where you can see the words that contribute to the classification. We also apply the Lime library to a same classification as against vaccination. The shape libraries was used to apply explainability, generate an overview of the model behavior. The L5 explainable model is also used in evaluation the overall behavior of the trained model. Overall, 75% of the samples analyzed in favor of vaccination. The distribution among the states was uneven. Most of posts come from the states of São Paulo, Rio de Janeiro, and Minas Gerais. Positive posts were based on collective wellness and health, supporting the health care system, and also on political views. Opposition posts were based on the fear of the risks of a vaccine developed so quick that such the possible side effects and the obligation to vaccinate children and adolescents, teenagers, when would a group at low risk of contamination. In general, the point presents the most the test with a relation with the freedom of choice. About the explainable tools, the point of emphasis use a tool for analysis on only on one sample in contrast to the tools for global analysis. Thank you.
Thank you. Any question now? No? No question? Okay. I don't see the use presenter. So, thank you all for your work, and the session has ended now.
Thank you.
Thank you.